So here we have in the NFPA 13 code book, the engineer has to calculate all the resistance between the sprinkler and the valve station itself. So what he's got here is this formula. I knew it at one point. I don't know it by heart anymore, to be honest. But what he's got to calculate is the friction loss, the length of pipe for the friction loss, the density of the fluid, because it could be any kind of fluid. It could be oil or water or antifreeze. The flow in the pipe or the kind of pipe, and the diameter. He's got to calculate all that. And he's also got to talk about or explain the velocity which the water flows in gallons per minute, and inside diameter of the 1-inch pipe or 4-inch pipe or 6-inch pipe or whatever. It depends on what he's calculating. But in this case, in a fire sprinkler system of 1-inch pipe blaze, he's gonna calculate everything for me and give me a summary at the end, 2 sprinklers. So in this case, this house I'm doing on Garden Drive, he's got the total flow from all reference points. He's got 5 PSI or 5 gallons per minute. And minimum flow of all operating sprinkler heads is 13 gallons per minute. Average flow from operating sprinkler head is actually only 13. It's almost the same. And total flow from all operating sprinkler heads, which is 2 of the highest and farthest sprinkler from the valve room, is 26 PSI, or gallons per minute, sorry. And the total demand on the whole system is 31 gallons per minute. Specifying available pressure at node. So he's got a reference on the plans where he's talking about a node, and he's got 143.70 feet of pipe to that node, and he's got a conversion of 62.3 psi to calculate from those reference points. Going down the list, he's got a required pressure for minimum flow, and at 95.8 feet of pipe, he needs 41.49 psi, and available pressure minus required pressure is 47.9 feet, or 20.74. So basically, he adds all these up, and he subtracts it from the main PSI coming in, and he's got a remainder of 20.74 psi, and that's how he calculates from end sprinkler to valve room. And for me, it's important to know what's remaining, which is, I got a lot. I got 20.74 psi. Typically, sometimes, well, not sometimes, but typically in Vancouver, I have less than that. Sometimes I have 5 psi, and I gotta watch out how many 90s I use. So I'll take you through a little run through of this house I'm doing, and I'll show you what the engineer is talking about. And he's talking about weight of water on the slopes and travel and length of pipe all the way back to the station, and he just summarizes how much we need to flow 2 sprinkler heads, and he subtracts it from the PSI at the main. And that's, and this is pretty quick summary. So here we go, coming into the house. This is a duplex, and we got the valve station on the right. I'm gonna go right there, riser up there, run down here, a couple of sprinkler heads, and then come up these stairs. Give me a second here. And then there's my riser going up, feeding a pendant here, one in the laundry room, concealed sidewall up there, and coming over here for a pendant, and that's one zone. And the second zone will come from the valve room, run along under the floor into this bathroom, underneath this bathroom, we got a riser up. Here I'm working on the intersection now. It's gonna feed the 2 risers, one there, one over there, and line for a sprinkler head here, sprinkler head between these 2 lights, and then one right here to get under the stairs and get out the hall. And that's one zone. Then we're just gonna go up to the top floor. Oh, and the compressor goes on. And then up here, here's the slope ceiling of an 812 pitch. We got 4 sprinklers up here. And 2 here. It's an 812 is a perfect 45, as you can see. We're like 27 feet up in elevation, and we're calculating for 2 sprinklers farthest from the valve room. Here they are above me on an 812 pitch. Now that's, you gotta account for slopes. Once it gets over 812, you gotta account for a different sprinkler head. A commercial head, a Globe 5.6 is probably what I would use rather than a 4.9. But we're at 812, so we can still use 4.9. The engineer will calculate from these 2 sprinkler heads back to the valve room coefficients, which is the resistance of inside diameter of the pipe. And he's going to calculate for fittings. He's going to calculate it for height, weight of water, all the way back to the valve room. He'll get a gallons per minute conclusion, converting it to PSI, subtracting it from the static pressure at the main coming in. And in the summary that I showed you before, you know that he has 20 PSI. That's a lot. That's a lot to work with. I can do anything I want in this house, and I'd still get away with it. But when you get a feeling at a 6,000 square foot house, now you get a feeling that when you get into a bigger house and you've read the PSI coming into the house is 70 PSI, you get a feeling, you know you can do 1-inch pipe, you know you can go for a 100-foot run. You know, when you get a low pressure of 50 PSI, you know you're not going to get to 27 feet up. With the 812 pitch, you might need a pump, you might need bigger pipe to avoid the pump, but you know, that's expensive fittings. So you get the idea, you know, you get the idea of what you can do and what you can't do. And that's the point of the show. How an engineer calculates, how you get the feeling of what you can do and what you can't do in a house. Going for an estimate, you know you can use 1-inch pipe, keep your costs down, so on and so forth. Cheers.